Hello everyone. In this video, I'm going to talk about the part type detect on the sorting station. So as you can see on the lifter, at the bottom over here we have three different part presence sensors. On wire 26, you can see here that's a infrared sensor, and 28 is the capacitive. On the back, which is 27, that's the inductive sensor. So we have three different type of parts. So with the aluminum part, all the three sensors will be activated. When the red part, plastic, loaded on the lifter, that will active capacitive and also the infrared. With the black plastic can only active the capacitive. So clearly, as you can see, this is a three sensor truth table, right? So if you want to recognize which type of part is loaded on the lifter, you need to use all these three combinations of these three sensors. And one challenge is that as you can see on here, only this capacitive sensor is mounted on the lifter, right? So the inductive and the infrared just mounted on the base, right? So it stayed on the base, and when the lift reads up, the only sensor reads with it is the capacitive. So that will be the situation, the combination, the value will change once the lift start to raise up, right? So that will present a challenge because the part type shouldn't change, right? Should remain the same until the part being ejected. So the lift raise up shouldn't change any of the part type detected by the PLC. But the challenge is your PLC program continue running, right? So once the lift start to move, and the sensor combination will change, right? So how do we preserve the part type once we detect it? So that's the challenge, right? So on the lab, as you can see on here, I basically already talked about that, right? So I just present that as a truth table, right? So with the wire number and different values, right? So that actually correspond to this, right? So it's just a digitalized, right? We have the tag value in here. So I mentioned the challenge on here, right? The lifter rates will change the combination. Also, there's another challenge I didn't mention on the slide is that these three sensors they have different response time. So that's what I found on the equipment, because different sensor has different response time, right? So once the part being loaded on here on the lifter, maybe one sensor will respond that part quickly earlier than the other, right? So they may all have different response time, right? So and also because of the arm over here load part, but they may have a different load position, maybe not exactly in the same spot. So that may also cause the response time different every time. So everything is changed. So that's the challenge here, right? So I gave you some tips. You need to have a time delay, one shot, some suggestions, large, unlarge, right? So what I want to mention over here is that my solution is not the only solution, right? So you should be able to find different solution. Myself, I already found the different type of program, different type of logic can do the job. But clearly, I only present one. I think it's the best one. You are encouraged to find any other type of solutions. If you do find a good solution, I'll be appreciate if you can share with me, right, with the solution. All right, let's look at my solution out here. So first, The other thing I want to talk about over here, this is what we're using the alias tag. You can see here all the tags are alias, right? So this is only for the commissioning phase. Later on, when we start with the design, all these tags should be buffered. We use memory tag, but the logic should remain the same. So speaking of that, the solution, okay, you can see here, based on the truth table, with all three different type of parts, the capacitive sensor will activate on all of them, right? So you can see here on this column, the wire 28 is the capacitive sensor. So that's why we can use this as the trigger. So because once it's on, that indicates there's a part it's loaded on the lifter, right? So then after that, we feed that into a on delay timer. So this one I set up as the 100 millisecond. That should be long enough. So to compensate all the differences between the three different sensors. So once the sensor, the timer done, right? Capacitor sensor being turned on after for 100 milliseconds, you can see the done bit. So that's the solution I use to solve the response time difference here, right? Because the capacitive sensor is always on, then we can use this as trigger to start the timer. Once the timer starts, we want to hold for 100 milliseconds, and then after that, we can continue to go on to do other type of logic process. Let me resolve on here. So that's you can see here. So again, once it's almost like the trigger, right? Then after that, I add a one shot. As you can see the comment over here, one shot prevents the re-entering once the lift moves up. Because as you can see, if you understand the one shot instruction, once all the trigger in front of here become true, the one shot only allow the logic go through this for once. Right. So once we pass through, it's like a one-time door. Once we have the door open for one scan, we go into there, and then followed by that is just directly translation from the truth table, as you can see here, right? So with both one, we use exam on. With the 0, we use exam off, right? So both zeros use exam off. Right, so that's the direct translation from the truth table on here. Then after that, we just latch. We latch different part type: illuminant, red, and black. Right. So, like I said, the one shot is like a one-time door, one scan. Right. So once we have the time delay, then we let the logic pass, and then by that time, we can assume all the three sensors are being activated, right? Being performed already on there. So then we can make a decision by that, right? As you can see on here, because we use the latch, we have to somehow unlatch it, clear it, right? Otherwise, it's gonna stay on. So then again, we just use this, right? So this is the capacitive sensor. When that turn off, that means there's no part on there. And that's the time we can erase, we can reset all the 3 bits into 0. So in this way, we have the solution with the part type. All right. So you can see on the back here, I have another second solution I'd like you to practice. So over here, we create 3 different Boolean tags to represent the part type. Then, of course, we can use a double integer tag then to represent the 3 different types by 3 different values. Right? So as you can see, the logic will be very, very similar to this once we understand this. Right? So we can just keep using the same type of logic, only we just let me zoom out a little bit so you can see that similarity, right? So between these 2 different solutions, we have the same over here up to this point, right? Just remember that you should use a different tag to represent timer and also one shot, right? You cannot share the tag. Then after that, conditions are the same, and then except the difference if you use Boolean tag, you use large. But if you have the double integer tag, you use move instruction to assign different values. All right, let me clear out. Then you can see the full solution with the double integer. So over here, right? So because it's double integer, right, we don't use large and large, but they're similar, right? So when you assign different double integer value, that value will stay there, until you assign different values. So that's when the power present capacitor become off, and then we clear all the value back to 0. All right. Again, you really encourage to try to find a different solution, and then we can maybe share different solutions. We can have a discussion. All right.